Yes, you're most welcome. In the same way we looked at calculating number of moles provided the mass of a certain chemical compound, we also want to look at calculating mass provided the number of what? Moles. In others, we are going to look at conversion of number of moles. Conversion of moles to what? To mass. That's what we want to look at today. Okay. So the same relationship will be used. 1 mole of the compound can be 1 mole of a compound or any substance. 1 mole of a substance weighs R, Fm, or R, M. So the 1 mole of a substance will be equivalent to the molecular mass or the formula mass of a substance. That's what we want to look at. So without wasting a lot of time, we shall go particularly to an example and we calculate that. Then we shall calculate some few questions, and then we shall also put some for trying out. Then after trying out, you reach the comment section and you post there. We shall be able to read your answer. In case of any additional information, we shall come in and we guide you appropriately. So the example we can be able to look at is example calculate the mass of the following. At A, mass of the following 0.25 moles of sodium carbonate. To 0.1 moles of 0.1 moles of calcium. Right? 2 moles of magnesium. Moles of magnesium carbonate. Then 4, we can say 3 moles of sodium hydroxide. Yes, this is what we are going to use to understand the concept of converting moles to what? To mass. We are saying that calculate the mass of the following, and we are saying that in part A, 0. Let us call this one my number 0.25 moles of sodium carbonate. Another one we are talking about 0.1 moles of calcium, then 2 moles of magnesium carbonate, and also 3 moles of sodium hydroxide. In this case, we have been provided with the number of moles, and we are supposed to get the mass in grams that are found within these moles, and that's what we are going to do. So let me hope you finish writing this. We are talking about 0.25 moles of sodium carbonate. We are also talking about 0.1 moles of magnesium carbonate. We are also talking about 2 moles of magnesium. The 0.1 was for calcium. Then we are talking about 2 moles of magnesium carbonate. We are talking about 3 moles of sodium hydroxide. Those are the ones that we are talking about as written here. Now, using that information we have, and we said that we are looking for 0.25 moles of sodium carbonate. That's the one we want to transfer to mass. Let us first get the RFM. of sodium carbonate. This one is 23. Sodium is 23 times 2 N plus. Carbon, which is 12, but it is 1 N plus. Oxygen, which is 16 times 3. So what shall we have? This is a 46 plus 12 plus 48. And the answer we are getting is 106. So the RFM of sodium carbonate is 106. Now, after getting the RFM, we want to transfer the number of moles we have to mass. What shall we do? We shall remember this 1 mole of a substance weighs its RFM. But what are we interested in? We are interested in the mass. Let us put mass on the right, and then we leave the moles that we have been provided with to the left, such that we can be able to calculate values. So since we have moles, we shall say 1 mole of which substance are we talking about? Sodium carbonate. Weighs the RFM, which is 106 grams. That's what we know. What about 0.25? Sodium carbonate. So if 1 mole weighs this, what about 0.25 moles of sodium carbonate? You will weigh 0.25 times 106 divided by 1. The answer you get will be in grams. So we have 0.25 times 106. The answer we are talking about is 26.5. So we are talking about 26.5 grams. These are grams of sodium carbonate. So we have obtained 26.5 grams of sodium carbonate. So in any way, we are just saying that 1 mole of that substance weighs the RFM, which is a substance sodium carbonate, and its RFM is 106. Now, 0.25 moles, which mass would they contain? So we are saying 0.25 moles of sodium carbonate. Where is? You make sure that in your calculation from first principles, if here you have moles, if you have moles here, even here you should have moles. If you have grams here, even here you should have grams. Therefore, the units should be corresponding to one another. This is what we have. Anyway, using the same approach, you can also be able to look for the number of moles. Sorry, the mass in 0.1 moles, the mass in 2 moles of magnesium carbonate, the mass in 3 moles of sodium hydroxide. Just a matter of calculating the relative formula mass or knowing the relative atomic mass of that substance, and you'll be able to calculate this. For example, the relative atomic mass of calcium is 40. You can come and say 1 mole of calcium weighs 40 grams. What about it? 0.1 moles, and you multiply like this, like there how we have said. Multiply this one times this divided by this. That's the way how you get the answer. In this one, for example, sodium hydroxide, you calculate 23 plus 16 plus 1, the answer is 40. That's the relative formula mass of sodium hydroxide. Now you say 1 mole of, where there is this now we put there, sodium hydroxide. 1 mole of sodium hydroxide weighs 40 grams. That's it. 1 mole of sodium hydroxide weighs 40 grams. What about 3 moles of sodium hydroxide? Now you multiply and you'll be able to obtain the answer. That's the way how we can be able to deal with that. Today we have converted moles to mass. Last time we converted the mass to moles, and I believe everything now is fine and moving perfect and smart. We shall continue from there when we meet next time. For any inquiry or any question, you can be able to send us a message. You can go to the comment section right there. We shall be able to reply. Today we have ended here. I wish you the best.